Hi folks, the purpose of this video is to introduce you to the interpretation of logistic regression results using probability statements. And the picture that I've got up in front of you is just to remind you a little bit about how logistic regression works. Imagine in the top frame here that we're looking at how a basketball did last season. And when they won a game, we put a little black mark up here. When they lost a game, we put a black mark down here. And across the bottom, we've got the number of injuries to key players. And what you can see is that going from one key injury to two key injuries to three key injuries did not have much of an effect on whether or not you won basketball games, because you won most of them. You lost a few, but you won most of them. However, once we go to 4 to 5, from 5 to 6, 6 to 7, and 7 to 8, what we're seeing is that all of a sudden you start to lose most of the games. And in fact, the key sweet spot here is somewhere between 3 and 5 injuries, and that's where you go from winning most games to losing most games. What that means in effect is that we have to interpret logistic regression a little differently than we do linear regression, because every 1 unit impact in the independent variable, in this case the number of key injuries, has a different effect on whether or not you win or lose the game. And in fact, what we really want to do, and what we're going to show you how to do in this video, is how do we predict the odds of winning, or rather the probability of winning with 2 injuries, say versus 3? Or what is your probability of winning on average if you have 5 injuries? So that's the first part of what I wanted to show you in this picture. The second part, what I wanted to do is to remind you, with logistic regression, just like regular regression, we can control for variables. So in this case, we could look at your probability of winning, looking at the effect not only of the number of injuries, but also looking at the second variable of whether you're playing away or whether you're playing at home. And in the model that I've got, imagine again that these dots had been colored such that you had wins at home in green and wins away in red, losses at home in green and losses in red. And in the bottom screen, I have a hypothetical bit of output on what 2 different curves might look like. And the reason why this is important is we might talk about the probability of winning if you have 1 injury at home, or 2 injury at home. I see I left 2 off there, or 3 injuries, and that would be different. And what we're going to learn how to do in the rest of the screencast is how we can toggle and assign, for example, the average number of injuries and see whether playing or away or at home, what the effect of that was impacting your probability. On the other hand, we could take the average effect of being away, which is effectively the curve up here, and we could look at the independent variable of number of injuries. In other words, the regression model will allow us to predict the number of injuries, effect on winning, controlling away or whether you're away from home or at home. The reverse is true too. We can predict whether or not you won or lost as a function of the number of key injuries you had. And the way that we might think about this is it may be that you're playing at home, that somebody who's slightly injured goes ahead and plays that night at the last minute when they were at home, but they might have not played when they were away. And so we might want to look at these 2 variables simultaneously, and that's the way we do it. Let's get a little more concrete here. And so I'm going to pop up some data. And in this data, we are going to analyze, go to binary logistic regression, and I've already plugged in the variables that we're going to be looking at. We're going to specifically be looking at whether or not a person voted for Hillary Clinton in 2016 as a function of whether they were a Democrat, which is a 0 to 1, whether or not they were an authoritarian, where the score of 12 is the lowest level of authoritarianism, and 84 is the highest, whether or not they were male, and then religiosity, where 7 is that they strongly agree that religion is important, and 1 is where they strongly disagree that religion is important. Now, I've got this regression set out. I'm going to go ahead and paste it rather than running it for reasons that I'll show you in a second. So I'm going to paste it here, and here comes the output. In order for us to talk about holding all other variables at their constant and changing the values of certain variables to see what the probability is at the low end of that range and at the high end of the range, we're going to have some descriptive statistics. And by pasting this regression, what it allows me to do is then to make sure that I have variables in the same order for a reason that I'll show you in a second. So quickly, let's just analyze descriptive statistics, descriptives, and I just randomly picked a variable age in years, and I'm going to paste it. Now I've got the descriptive statistics. Watch what I'm going to do. Move it above, and if I go ahead and choose my key variables here, I can just paste them in over that. And now what this means is I will get descriptives in exactly the same order as logistic regression, which will be important when we use the probability chart in a minute. So now let's go ahead and run both of these data sets. And I've got my descriptives at the top and my regression at the bottom. Now, in other videos, I've showed you how to interpret logistic regression, but what we're going to do here instead is to talk about probabilities. And so the first thing that I'm going to do is open this up so I can copy the variables that I'm going to need. And I'm going to need the constant. It's going to be the first value that I'm going to need, and I'm going to copy it. Now, if you've been following what I've been doing and talking about in class, or if not, you can download a spreadsheet from my web page. I have created a web sheet that will allow us to work with variables and to create probabilities. You don't need to know about the underlying math, but if you do, you can find this online if you want to, or you can read the Pollock workbook on this. But for our purposes, we're going to go ahead and spread or paste the constant coefficient. Notice this was not the odds ratio, this was the unstandardized coefficient. And the first thing that I need to do is put in that constant coefficient. So I'm going to put that there. Now I just need the independent variables, and I need their unstandardized coefficients, and then I'm going to use this scenario over here. Let's get going back to this output so we can do that. The first thing that we do, oops, we got to get to the results here. The first thing we're going to do is get our variable names, and we're going to get the unstandardized coefficient. I've already got the constant, so notice I'm just going to select the 1, 2, 3, 4 independent variables, and I went ahead and I grabbed their unstandardized coefficient, and I can paste that right into here. Now, I have to give a scenario for each variable. And how am I going to get the scenario? Let's begin by looking at assuming that you were a typical person. That is, you had the average value of each of our independent variables. What was your probability for voting for Hillary Clinton? In order to do that, my scenario is going to take me back up here to the descriptive statistics, and I'm going to choose the mean value for each of my variables. So the religious person, 3.69 was the average score on the 7-point scale. On that authoritarianism scale, which was a 77-point range, which varied dramatically. Again, as I recall, it was a low of 12 to a high of 84 or something like that. We'll have to go back and check that in a second to make sure that we get our scenario right. But in the meantime, we take the mean and we put them in. And what this means is that a person who was average on everything had a probability of voting for Hillary Clinton of about 46%. I'm going to actually take this code and I'm going to put it up here. Notice I copied the code, not the cell, because if I put it right here, it'll allow us, and then I'll color it just to keep it constant. That's something nice and light. And again, just because I'm doing a demonstration here, we'll flip this to probability. We'll just put it to percentage. So the typical person who was average with respect to partisanship, average with respect to authoritarianism, I know this sounds odd, but average with respect to gender, which means you just take, you had a 0.451 probability of being male. And religiosity, you had a 46% chance for voting for Clinton. But here's where the scenario comes in. 46% chance of voting for Clinton. What if you were not a Democrat? We can hold the effect of everything else constant and compare Democrat to non-Democratic person. All of a sudden, your probability of voting for Clinton is 0. Well, what if you were a non-Democratic female? Not surprisingly, that increases, controlling for the effect of partisanship, that increases your odds of voting for Clinton, and so on. So I'm going to undo those, which I just did. Let's go back and let's assume with authoritarianism that we want to know what is somebody with the lowest rate of authoritarianism, what is their probability of voting for Clinton versus the highest rate. And just reminding me of what my authoritarian index was, you could vary from 12 points to 84 points. And so let's take authoritarianism and let's give you the lowest score. If you had the lowest score of 12, your probability of voting for Clinton was about 90.75, 91%, so almost a sure thing. In other words, even controlling for the partisan effect, even controlling for gender, even controlling for religiosity, if you had very, very low authoritarianism, the lowest possible, you had a 90% chance. Well, what if you had the highest? You had under a 7% chance of voting for Clinton. So this is how we create scenarios. Rather than talking about odds ratios that can be abstract, we could say, what were your odds of voting for Hillary Clinton if you were a non-Democrat who had typical levels of authoritarianism but were an especially unreligious person? And they were about 24.5%. How do we do this in practical terms? If you look at any of the articles that I've got on as sample articles, I oftentimes will use logistic regression, and I say any. In fact, all of the models that I've got online of examples of work have work where there will be one table or another that basically, getting all the way back here, let's go back to where everybody is at their average, that begins with a probability chart that shows that if somebody was average of everything, they would have a 46% chance of doing whatever the outcome is. And then what I do for each variable is I predict the probability at the lowest value, in this case a non-Democrat 24% chance of voting for Clinton, and at the highest level, controlling for every other variable at its typical value. So we can talk about the effect of minimum to maximum score, the change, for being Democrat versus non-Democrat, holding every other variable at its constant. And if I was doing a table, I might now put this back to its mean and change authoritarianism to its lowest, and then count a score with it at its highest, and put that into a chart, and now go back to my mean. Whether or not you were a male at its lowest, in other words, you were a female, 53% chance of voting for Clinton, holding other variables at their constant effect, versus being male, 40% chance of voting for Hillary Clinton, holding the effect at their constant, and so on. And that, my friends, is how we take odds ratios and we create probability statements. Back to our basketball example at the beginning, what this would allow you to do is to assign the average probability or the average effect of winning, whether you were away or whether you were at home, and then to look at the number of key injuries. You could say, what's the probability of winning when you have one injury? What's the probability of winning when you have 3 injuries? What's the probability 5, and so on. And that's a heck of a lot easier to interpret than logistic regression coefficients that are unstandardized, which are impossible to interpret just off the top of your head. But frankly, this is a lot better than odds ratios. So hopefully you'll find this helpful, and I'm glad that you took the time to watch the video.